Hey everyone, and welcome to our deep dives on 5th grade math.
Yeah, 5th grade.
We're going to be taking a look at
A lot of stuff.
a lot of stuff.
It's exciting.
Addition, subtraction, fractions, division number sentences, multiplication time capacity, and volume 2D shapes, 3D objects.
All the good stuff.
All that good stuff that you learn in the 5th grade.
Yeah.
We're going to take a deep dive into all of that today. So
Let's get started.
let's jump right in. First up, we're going to talk about addition and subtraction.
Okay.
So addition and subtraction, they're sort of like the basis of everything.
Yeah, the foundation.
The foundation of all math. Everybody knows how to do the column method. I'm sure most people know how to do the column method. 345 plus 678 equals 123. And then same thing with subtraction. 823 minus 456 equals 367.
Yeah, and there are diagrams in the study guide that actually walk you through that. So if you need that visual aid,
Yeah.
you got it.
If you're a visual learner, you can see how that works.
Definitely. And you can see how problem solving comes into play, right? Like if Maria has 25 apples and John has 32 apples, how many apples do they have together? Well, we can use addition to figure that out. 25 plus 32 equals 57 apples.
That's right.
Yeah.
And did you know that the plus and minus symbols that we use today, those weren't actually widely used until the 16th century.
Wow, I did not know that.
Yeah, isn't that interesting?
Very cool.
So think about this. We've been talking about the column method, but what are some other ways that you can add and subtract? Maybe you could use a number line. Maybe you could do some mental math.
Oh, yeah.
There's all sorts of ways to approach it.
Lots of ways.
So, okay, let's get to these quiz questions because I know we want to, tip our knowledge and see how much we remember about addition and subtraction.
Yes.
So the first question, what is the sum of 1234 and 5678?
Okay, so sum means we're adding, right?
Right, we're adding.
So 1234 plus 5678.
And the answer is 6901.
Okay.
Next question, subtract 345 from 789.
All right, so 789 minus 345.
And that would give you 444. Got it. Last question. If you have 50 candies and eat 23, how many are left?
Okay, so we're subtracting again. 50 minus 23.
Equals 27.
All right.
So there you have it, addition and subtraction.
On to the next one.
Let's move on to fractions, shall we?
Yes, fractions.
So fractions, they can seem kind of intimidating at first,
Just a little bit.
but really they're just a way of representing parts of a whole.
Right, like slices of a pie.
Yeah, like if you have a pizza and you cut it into 4 slices.
Okay.
Each slice is 1/4 of the whole pizza.
Exactly.
And we write that as 1/4.
And that top number is called the numerator, and the bottom number is called the denominator.
That's right. So the numerator tells you how many parts you have, and the denominator tells you how many parts the whole is divided into.
So if you have the fraction 3/4, that means you have 3 out of 4 slices of that pizza.
Exactly. Now, what about finding a fraction of a group? Like, what if you have 12 oranges, and you want to know what 2/3 of that is?
That's where multiplication comes in handy. We can multiply 2/3 by 12 to find out.
And that gives you 8 oranges.
Exactly.
Now, the study guides also talk about adding and subtracting fractions with the same denominator.
Uh-huh.
So like 1/5 plus 2/5, that would give you 3/5.
Yeah, because the denominator stays the same. We just add the numerators.
Right. And then there are also these things called mixed numbers.
Oh, yeah, mixed numbers.
Like 2.5.
Those are fun.
Yeah, so that means you have 2 whole things and then half of another thing.
Right.
Okay, so now let's talk about comparing fractions, because sometimes you need to know which fraction is bigger or smaller.
Okay.
And one way to do that is to use visuals, like fraction bars or circles.
Right.
So if you look at a fraction bar that's divided into fourths,
Uh-huh.
you can see that 1/2 takes up more space than 1/4.
So 1/2 is bigger.
Yeah, exactly.
That makes sense.
Did you know that we use fractions all the time in everyday life?
Oh, yeah, all the time.
Like when you're sharing a pizza or measuring ingredients for a recipe.
Absolutely. Or when you're telling time like 3:30.
Yeah, or when you're splitting the bill at a restaurant.
It's everywhere.
So think about this. What are some other ways that you can visualize fractions? Maybe you could use Legos or blocks or even draw pictures.
Oh, yeah, that's a good idea.
Anything that helps you see the parts in the whole.
Definitely.
Okay, now for the fraction quiz questions.
Hit me.
First question. What is 1/4 of 20?
Okay, so we can think of it like dividing 20 into 4 equal groups,
Right,
which would give us 5 in each group.
exactly. So the answer is 5.
Okay.
Next question, add 3/8 and 2/8.
So they have the same denominator, so we just add the numerator.
Right.
So 3 plus 2 is 5, so the answer is 5/8.
Exactly.
Okay.
Last question. Which is greater, 2/3 or 1/2?
Okay, so if we think about those fraction bars, again, 2/3 takes up more space than 1/2.
Right, so 2/3 is greater.
Awesome.
Okay, so that's fractions.
That was fun.
I know, right? Now let's move on to division.
Okay, division.
Okay, so first we need to talk about factors and multiples.
Right.
So factors are numbers that divide evenly into another number.
Okay.
Like the factors of 12 are 1, 2, 3, 4, 6, and 12.
Right.
And multiples are the results of multiplying a number by another whole number.
So like the multiples of 3 are 3, 6, 9, 12, 15, and so on.
Exactly. Now, here's a key relationship. Multiplication and division are inverse operations.
What does that mean?
It means they undo each other.
Oh, okay.
So if 12 divided by 3 equals 4,
Mm-hmm.
then 4 times 3 equals 12.
Oh, that makes sense.
They're like two sides of the same coin.
I get it.
Now for long division or short division, we can use a technique called the house method.
The house method.
Yeah, it's kind of a visual way of organizing the division problem.
Okay.
And it's all about breaking down the problem into smaller steps.
So it's like building a house brick by brick.
Exactly.
Mm-hmm.
Now let's talk about how division is used in the real world. Like imagine you have 20 candies and you want to share them equally among 4 friends.
Okay.
You would use division to figure out how many candies each friend gets.
So 20 divided by 4 equals 5 candies each.
That's right. Did you know that division is used in all sorts of professions, like scientists, engineers, and even chefs?
Wow, that's cool.
Now think about this. How can you use multiplication to double-check your division results?
Oh, that's a good idea. So if you divide 12 by 3 and get 4, you can multiply 4 by 3 to make sure you get back to 12.
Exactly. It's a good way to catch any mistakes.
I like it.
Okay, time for the division quiz questions.
Bye, bring it on.
First question, what are the factors of 24?
Okay, so factors are numbers that divide evenly into 24.
Right.
So we've got 1, 2, 3, 4, 6, 8, 12, and 24.
Exactly.
That-
Next question, what is 455 divided by 7?
Okay, that one might require some long division,
Right.
but the answer is 65.
65, that's right. Last question, if you have 60 cookies and want to make cookie bags with 12 cookies each, how many bags can you make?
Okay, so we're dividing the total number of cookies by the number of cookies per bag.
Right.
So 60 divided by 12 equals 5 bags.
5 bags of delicious cookies.
Yeah.
All right, so we've tackled addition, subtraction, fractions, and division.
We're on a roll.
Now let's move on to number sentences.
Okay, number sentences.
So number sentences are kind of like mathematical expressions that represent a problem.
So they're like the language of math.
Yeah,
Okay.
exactly.
Yeah.
So for example, if the problem says John has 5 apples and gets 3 more,
Uh-huh.
we can write that as the number sentence 5 plus 3 equals, and then we solve for the unknown, which would be 8.
Right.
And number sentences can involve any of the operations we've talked about so far: addition, subtraction, multiplication, division.
They're like a toolkit for solving problems.
That's a good way to put it. Now, did you know that number sentences are used in all sorts of real-world situations? From calculating budgets to designing experiments, they're everywhere.
Wow, I didn't realize that.
So think about this. How can you use number sentences to make challenging math problems less intimidating? Yeah, maybe you could try breaking down the problem into smaller steps and then writing a number sentence for each step.
Oh, that's a good idea.
Anything that helps you make sense of the problem and see the connections between the different parts.
Definitely.
Okay, let's try some number sentence quiz questions.
Okay.
First question, write the number sentence for Sarah, has 12 books and gives away 4.
All right, so that would be 12 minus 4 equals, and then we'd solve for the unknown, which would be 8.
Right, 8 books left.
Okay.
Next question, solve 7 times 8.
That's 56.
56, that's right. You know your multiplication facts.
Oh, hi.
Last one, if x plus 5 equals 10, what is the value of x?
Ooh, a little algebra.
Yeah, just a little bit.
So we need to isolate x, so we subtract 5 from both sides of the equation, and that gives us x equals 5.
Exactly.
Okay.
All right, so that's number sentences.
That was fun.
Now let's move on to multiplication. It's all about efficiency and repeated addition.
Right, so instead of adding the same number over and over again, we can just multiply.
Exactly. Like
Yeah.
4 times 5 is the same as adding 4 to itself 5 times.
Which is 20.
Right. But when we're dealing with larger numbers,
Hmm.
we need more efficient methods like the standard algorithm or partial products.
Yeah, those are lifesavers.
And multiplication isn't just for numbers, it's also useful for comparing quantities expressed in different units.
Oh, like if 1 meter equals 100 centimeters,
Exactly.
we can use multiplication to find out how many centimeters are in 3 meters.
Right, which would be 3 times 100 or 300 centimeters.
That's right.
And of course, multiplication is essential for solving all sorts of word problems.
Absolutely.
Did you know that multiplication is used in countless fields, from finance and engineering to computer science and even music?
Wow, really? I didn't know it was that widespread.
It's everywhere. Speaking of connections, think about this. How can you use multiplication to simplify calculations in your everyday life?
Huh?
Maybe you could use it to figure out the total cost of multiple items at the grocery store.
Oh, that's a good idea.
Or maybe you could use it to calculate the area of a rectangular garden.
I like it.
Okay, ready for some multiplication quiz questions?
Hit me.
First question, multiply 345 by 23.
Okay, so that's a bit of a challenge, but using either the standard algorithm or partial products, the answer is 935.
That's right.
Okay.
Next question, if 1 kilogram is equal to 1,000 grams, how many grams are in 4 kilograms?
Okay, so we just need to multiply 4 by 1,000, which gives us 4,000 grams.
4,000 grams, exactly. Last question, if each student needs 2 notebooks, how many notebooks are needed for a class of 30 students?
Okay, so we multiply the number of students by the number of notebooks per student.
Yeah.
So 30 times 2 equals 60 notebooks.
60 notebooks, that's right.
Okay.
All right, so we've mastered multiplication.
We're on roll.
Now let's move on to time.
Time.
Okay, so first things first, can you confidently read time on both analog and digital clocks?
I think so.
Okay, good.
Yeah.
So remember, an analog clock has the hour hand and the minute hand. And a digital clock just displays the time numerically.
Right.
And then we also have different time systems, 12-hour time with AM and PM, and 24-hour time, which is a continuous count throughout the day.
Okay.
So 3 p.m. in 12-hour time is the same as 1500 in 24-hour time.
Got it.
Now, the study guides also talk about converting between different units of time, like seconds, minutes, hours, days, weeks, months, even years.
Right.
It's all about understanding the relationships between those units.
Like how 60 seconds make up a minute.
Exactly.
And 60 minutes make up an hour.
Right. And then there's also calculating time durations, like figuring out how long an event lasted.
Oh, yeah.
Now, did you know that a leap year has 366 days instead of the usual 365?
Oh, that's right, because of that extra day in February.
Exactly.
It's a fun fact.
Now, think about this. Why do we have different time zones across the globe? It's all connected to the Earth's rotation and our need to synchronize time across vast distances.
That's pretty amazing when you think about it.
It is right. Okay, let's try some time-themed quiz questions.
Okay.
First question, what is 1800 in 12-hour time?
All right, so that's 6 hours after noon, which would be 6:00.
6:00 p.m., exactly.
Right.
Next question, how many minutes are in 3 hours?
Okay, so there are 60 minutes in each hour.
Right.
So 3 hours would have 3 times 60 minutes, which is 180 minutes.
180 minutes, that's right.
All right.
Last question, if a movie starts at 7:30 p.m. and lasts for 2 hours, what time does it end?
Okay, so we just add 2 hours to the start time,
right.
which gives us 9:30 p.m.
9:30 p.m. movie time.
Yes.
All right, so that's time.
That was fun.
Now let's move on to capacity and volume.
Okay, capacity and volume.
So
Yeah.
capacity is the amount of liquid a container can hold,
Okay.
like, measuring cups and jugs and things like that.
Right.
And we use units like milliliters and liters to measure capacity. And remember, 1 liter is equal to 1,000 milliliters.
Right.
Now, volume is the amount of space a three-dimensional object occupies,
Okay.
like a box or a ball or something like that.
So it's like how much stuff can fit inside something.
Yeah, exactly.
Okay.
Now, did you know that capacity and volume are actually closely related?
How so?
Well, if you fill a container with liquid, the volume of the liquid is equal to the capacity of the container.
Oh, that makes sense.
Yeah, so they're kind of two sides of the same coin.
I get it.
Now think about this. How does understanding capacity and volume help you in everyday life? Maybe you could use it to make sure you buy a big enough container for your leftovers.
Oh, that's a good one.
Or maybe you could use it to figure out how much water you need to fill up a swimming pool.
Yeah, that would be helpful.
Okay, let's try some capacity and volume quiz questions.
Okay.
First question, convert 2 liters to milliliters.
All right, so remember, 1 liter is equal to 1,000 milliliters. So 2 liters would be 2 times the 1,000 milliliters, which is 2,000 milliliters.
2,000 milliliters, that's right.
Okay.
Next question, if a jug holds 1.5 liters
Yeah.
and you pour out 250 milliliters, how much is left?
Okay, so first we need to convert 1.5 liters to milliliters, which is 1,500 milliliters.
Right.
Then we subtract the 250 milliliters that was poured out, which leaves us with 1,250 milliliters or 1.25 liters.
1.25 liters, exactly.
Okay.
Last question. If 1 cup holds 200 milliliters, how many cups can you fill from a 2-liter bottle?
Okay, so we need to divide the total volume of the bottle, which is 2,000 milliliters, by the volume of 1 cup, which is 200 milliliters.
Right.
So 2,000 divided by 200 equals 10 cups.
10 cups. That's
Yeah.
right.
Okay.
So that's capacity and volume.
We did it.
Now let's move on to 2D shapes.
2D shapes.
Okay, so 2D shapes are flat shapes like squares, triangles, circles.
Right, they only have 2 dimensions, length and width.
Exactly. And each shape has its own unique set of properties.
Like the number of sides and the number of angles.
Right. So a triangle always has 3 sides and 3 angles, no matter what size or shape it is.
And a square has 4 equal sides and 4 right angles.
Exactly. And a circle is perfectly round with no sides or angles.
It's all about those curves.
Now, did you know that 2D shapes are used everywhere in design?
Oh yeah, all the time.
From logos to architecture to patterns in nature.
It's true. Think about the honeycomb pattern in a beehive or the intricate designs on a butterfly's wings.
They're all based on geometric shapes.
It's amazing.
So think about this. Can you find examples of 2D shapes in your surroundings? Look around your house or your classroom or even outside and see what shapes you can spot.
I'm gonna do that right now.
Okay, let's test your 2D shape knowledge with these quiz questions.
Okay.
First question, how many sides does a pentagon have?
A pentagon has 5 sides.
5 sides, that's right.
Okay.
Next question, what's the difference between a square and a rectangle?
All right, so both shapes have 4 sides and 4 right angles. But the difference is that a square has all 4 sides equal, while a rectangle only has opposite sides equal.
Exactly.
Okay.
Last question, draw a pattern using triangles and squares.
Ooh, that's a fun one. I'm gonna let my creativity flow.
Be creative. All
Narrate.
right, so that's 2D shapes.
That was interesting.
Now let's move on to 3D objects.
3D objects.
Okay, so 3D objects are solid shapes like cubes, spheres, pyramids, cylinders.
Right. They have 3 dimensions, length, width, and height.
Exactly. And just like 2D shapes, each 3D object has its own unique set of properties.
Like the number and shape of faces, the number of edges, and the number of vertices.
Now, vertices, those are the points where the edges of a 3D object meet.
Like the corners of a cube.
Exactly. So a cube has 8 vertices, 12 edges, and 6 square faces.
And a sphere has no faces, edges, or vertices because it's perfectly round.
That's right. Now, what about those nets we talked about earlier?
Oh yeah, nets.
So nets are 2D shapes that can be folded up to create 3D objects.
It's like having a blueprint for building a 3D shape.
Exactly. So if we unfold a cube, we'd get a net made up of 6 squares all connected together.
And the net of a cylinder would consist of 2 circles for the bases and a rectangle that wraps around to form the curved surface.
Exactly. It's pretty cool, isn't it?
Yeah.
Now, did you know that nets are used in all sorts of practical applications?
Like what?
Like packaging design.
Oh yeah.
Manufacturers use nets to create boxes, cartons, and other containers that can be easily assembled.
That makes sense.
So think about this. Can you visualize the nets of different 3D objects? It's a great way to improve your spatial reasoning skills.
I'm gonna try that.
Okay, let's test your 3D object knowledge with these quiz questions.
Okay.
First question, how many vertices does a rectangular prism have?
Okay, so a rectangular prism is like a box.
Right.
It has 8 vertices, just like a cube.
8 vertices, that's right.
Okay.
Next question, what's the key difference between a pyramid and a cone?
All right, so both shapes have a point at the top, but a pyramid has a base that's a polygon, like a square or a triangle.
Right.
While a cone has a circular base.
Exactly. Last question, can you draw the net of a cylinder?
All right, so we need 2 circles for the bases, and then a rectangle that wraps around to connect them.
Right. That gives us the curved surface of the cylinder.
Exactly.
Fantastic job. You're a 3D shape master. Now let's move on to measuring those shapes and figuring out things like perimeter area and volume.
Okay, measuring time.
So we already talked about perimeter earlier, which is the total distance around the outside of a 2D shape.
Right.
Now let's focus on area, which is the amount of space inside a 2D shape.
Okay.
So we're talking about a square. The area would be all the space inside that square.
Right.
And we can calculate area by counting squares on a grid or by using formulas specific to each shape.
Like for a rectangle, we multiply the length by the width to get the area.
Exactly.
And for a square, we just multiply the length of one side by itself.
Right. Now, what about volume? That's the amount of space a 3D object occupies, right?
Exactly. It's like measuring how much water a container can hold or how much air is inside a balloon.
So how do we calculate volume?
Well, we can count unit cubes,
Oh.
or we can use formulas specific to each 3D shape. Like for a cube, we multiply the length of one side by itself 3 times.
Right?
And for a rectangular prism, we multiply the length, the width, and the height.
Exactly. And remember, volume is always measured in cubic units, like cubic centimeters or cubic meters.
Right.
So it's like we're imagining tiny cubes filling up the space inside a 3D object.
I like that.
Now think about this. How are perimeter area and volume all connected?
Well, they're all about measuring different aspects of a shape's size.
Right.
But in different dimensions.
Exactly. It's like looking at a shape from different perspectives.
That's a good way to put it.
Okay, let's put your knowledge to the test with those quiz questions.
Okay.
First up, what is the area of a square with a side length of 6 centimeters?
All right, so we multiply the side length by itself. 6 centimeters times 6 centimeters, which gives us 36 square centimeters.
36 square centimeters, that's right. Next question. What is the perimeter of a rectangle with a length of 8 centimeters and a width of 5 centimeters?
Okay, so we need to add up the lengths of all 4 sides. So 8 centimeters plus 5 centimeters plus 8 centimeters plus 5 centimeters, which equals 26 centimeters.
26 centimeters, exactly.
All right.
And last but not least, what is the volume of a cube with a side length of 3 centimeters?
Okay, so we multiply the side length by itself 3 times. 3 centimeters times 3 centimeters times 3 centimeters, which equals 27 cubic centimeters.
27 cubic centimeters. Fantastic.
We did.
Okay, so that's perimeter area and volume.
We're really covering a lot of ground here.
I know, right? But we're almost done with this part.
Okay.
Just one more topic to cover.
What's that?
Number sentences.
Number sentences.
Yeah. So remember, number sentences are those mathematical expressions that help us solve word problems.
Right, they're like translating words into math.
Exactly. And they can involve all sorts of operations like addition, subtraction, multiplication, and division.
So for example, if the problem says Tom has 10 cookies and eats 4, we can write that as the number sentence 10 minus 4 equals, and then we solve for the unknown, which would be 6 cookies left.
Right. 6 delicious cookies.
Yeah.
Now, did you know that number sentences are used in all sorts of real-world situations?
Oh, yeah, like what?
Like from calculating budgets to designing experiments, they're everywhere.
That's pretty cool.
It is, right? So think about this. How can you use number sentences to make challenging math problems less intimidating?
Well, maybe you could try breaking down the problem into smaller steps.
Right.
And then writing a number sentence for each step.
Exactly. That can make it a lot easier to manage.
I like that.
Okay, let's try some number sentence quiz questions.
Yeah.
First up, write the number sentence for Tom has 10 cookies and eats 4.
Okay, so that would be 10 minus 4 equals, and then we'd solve for the unknown, which would be 6.
6, that's right.
Okay.
Question 2, solve 9 times 6.
That's 54.
54, that's right. You're a multiplication whiz. And last one. If y minus 3 equals 7, what is the value of y?
Okay, so we need to isolate y.
Uh-huh.
So we add 3 to both sides of the equation,
Right.
and that gives us y equals 10.
Y equals 10, that's right.
All right,
Okay, so that's number sentences.
that was fun.
And that wraps up part 1 of our deep dive on 5th grade math.
Wow, we covered a lot of ground.
You did right. But don't worry, we'll be back for part 2, where we'll tackle even more math concepts.
I can't wait.
So stay tuned.
Okay, so, we left off talking about shapes last time, 2D shapes.
Yeah, we were talking about 2D shapes.
Let's dive a little deeper here.
Okay, so we were talking about triangles, squares, rectangles, circles.
And how those are used all the time.
Yeah, they're like everywhere you look.
Everywhere you look.
Design, architecture, nature.
Yeah.
It's pretty amazing.
So think about this.
Right.
Why are those shapes used so much? Like, why do we see them everywhere?
Well, I think it's because they're kind of like the most basic building blocks of geometry.
Yeah, that's a good point.
They're simple, but they can be combined in so many different ways to create more complex shapes and patterns.
Right. Like, think about a house.
Okay.
It's basically made up of rectangles and triangles.
Yeah, and then you can add circles for windows and arches and stuff like that.
Exactly. And then you can get even more creative with the decorations and stuff.
Yeah, like you could use patterns of squares and triangles to create a mosaic.
Or you could use circles to make a spiral design.
It's really endless, the possibilities.
It is. And what's really cool is that these shapes also appear in nature.
Oh yeah, tell me about that.
Like, have you ever looked at a snowflake up close?
Yeah, they're beautiful.
They are, and they're made up of these intricate hexagonal patterns.
Hexagonal.
Yeah, hexagons are 6-sided shapes.
Oh wow, I didn't know that.
Yeah, and they're super strong and efficient, which is why you see them a lot in nature. like in honeycombs too.
So those bees are little mathematicians.
So
That's amazing.
it seems like shapes are not only beautiful, but they're also functional.
Yeah, they are. And speaking of functionality, did you know that shapes are also used a lot in engineering?
Oh, yeah. How so?
Well, like think about bridges and buildings.
Oh,
They have to be designed in a way that's structurally sound.
right. They can't just fall apart.
Exactly. And so engineers use their knowledge of shapes and geometry to make sure that these structures are strong and stable.
So, like, they use triangles to make things stronger because triangles are really stable shapes.
Yeah, exactly. Triangles are super strong because they distribute weight evenly.
That makes sense.
And it's not just engineers who use shapes.
Yeah.
Artists use shapes too.
Oh, yeah, of course.
Like painters and sculptors use shapes to create their art.
Right. And graphic designers use shapes to create logos and illustrations.
Exactly. Shapes are everywhere.
They really are.
Okay, so let's do a little quiz to test our shape knowledge.
Okay.
First question. How many sides does an octagon have?
An octagon has 8 sides.
8 sides, that's right.
Okay.
Next question. What is the difference between a parallelogram and a rectangle?
Okay, so both shapes have 4 sides and opposite sides are parallel.
Right.
But the difference is that a rectangle has 4 right angles,
Uh-huh.
while a parallelogram doesn't necessarily have to.
Exactly.
Okay,
Last question. Can you name a shape that has 5 sides?
that would be a pentagon.
A pentagon, that's right.
Okay.
All right, so we've talked about 2D shapes now. Let's move on to 3D objects.
Okay, 3D objects.
So remember, 3D objects are solid shapes like cubes, spheres, pyramids, cylinders.
Right, they have length, width, and height.
Exactly. And they're made up of 2D shapes.
How so?
Well, like a cube is made up of 6 squares,
Oh yeah, that makes sense.
and a cylinder is made up of 2 circles and a rectangle.
Right.
Now remember those nets we talked about earlier?
Yeah,
Those are the 2D shapes that you can fold up to create a 3D object.
it's like unfolding a box.
Exactly. So if you unfold a cube, you get a net that's made up of 6 squares.
And if you unfold a cylinder, you get 2 circles and a rectangle.
That's right. Now think about this. Can you visualize the nets of different 3D objects in your head? It's a great way to practice your spatial reasoning skills.
I'm gonna try that.
Okay, let's do a 3D object quiz.
Okay.
First question. How many edges does a triangular prism have?
Okay, so a triangular prism has 2 triangular faces and 3 rectangular faces.
Right.
So it has 9 edges.
9 edges, that's right.
Okay.
Next question. What is the difference between a cone and a pyramid?
All right, so a cone has a circular base and a curved surface that tapers to a point,
Uh-huh.
while a pyramid has a polygonal base and flat triangular faces that meet at a point.
Exactly.
Okay.
Last question. Can you draw the net of a cube?
Okay, so a cube has 6 square faces.
Right.
So the net would have to have 6 squares all connected together.
And they have to be arranged in a way that they can be folded up to make a cube.
Right,
Okay, good job.
we did it.
So we've talked about 2D shapes and 3D objects. Now let's move on to measuring those shapes.
Okay.
So remember we talked about perimeter, which is the total distance around the outside of a 2D shape.
Right.
Now let's talk about area, which is the amount of space inside a 2D shape.
Okay.
And volume, which is the amount of space inside a 3D object.
So perimeter is like a fence around a yard, and
Yes.
area is like the grass inside the fence.
Exactly. And volume is like the air inside a balloon.
I like those analogies.
So how do we calculate these things? Well, for perimeter, we just add up the lengths of all the sides.
Right.
For area, we use formulas that are specific to each shape.
Like for a rectangle, we multiply the length by the width.
Exactly.
Yep.
And for a square, we just multiply the length of one side by itself.
Right.
And for volume, we also use formulas that are specific to each shape.
Like for a cube, we multiply the length of one side by itself 3 times.
Exactly. And for a rectangular prism, we multiply the length, the width, and the height.
Right.
Now think about this. How are perimeter, area, and volume all connected?
Well, they're all about measuring different aspects of a shape's size, but in different dimensions.
Exactly. Perimeter is a one-dimensional measurement.
Okay.
Area is a two-dimensional measurement. And volume is a three-dimensional measurement.
That makes sense.
So they're all related, but they measure different things.
I see.
Okay, let's do a measurement quiz.
Right.
First question. What is the area of a triangle with a base of 10 centimeters and a height of 6 centimeters?
Okay, so the formula for the area of a triangle is 1/2 base times height.
Right.
So we plug in the numbers and get 1/2 times 10 centimeters times 6 centimeters, which is 30 square centimeters.
30 square centimeters. That's
Yeah.
right.
Okay.
Next question. What is the volume of a rectangular prism with a length of 8 centimeters, a width of 5 centimeters, and a height of 4 centimeters?
All right, so we multiply the length, the width, and the height.
Uh-huh.
So 8 centimeters times 5 centimeters times 4 centimeters, which is 160 cubic centimeters.
160 cubic centimeters, that's right.
Okay.
Last question, what is the perimeter of a square with a side length of 9 centimeters?
Okay, so a square has 4 equal sides.
Right.
So we just multiply the side length by 4.
Uh-huh.
So 9 centimeters times 4, which is 36 centimeters.
36 centimeters, you got it.
Right.
So that's perimeter, area, and volume.
We're really making progress.
I know, right? Now let's move on to number sentences.
Number sentences.
So remember, number sentences are mathematical expressions that we can use to solve word problems.
Right, they help us translate words into math.
Exactly. And they can involve all sorts of operations like addition, subtraction, multiplication, and division.
So for example, if the problem says Sarah has 12 apples and gives 4 to her friend, we can write that as the number sentence 12 minus 4 equals, and then we solve for the unknown, which would be 8 apples left.
Right.
Now, did you know that number sentences are used in all sorts of real-world situations, like from calculating budgets to designing experiments?
It's true, they're a really powerful tool for problem solving.
So think about this. How can you use number sentences to make challenging math problems less intimidating? Maybe you could try breaking down the problem into smaller steps and then writing a number sentence for each step.
That's a great strategy.
Yeah.
It can make even the most complicated problems seem manageable.
I like it.
Okay, let's do a number sentence quiz.
All right.
First question, write the number sentence for John. Has 7 marbles and wins 3 more.
Okay, so that would be 7 plus 3 equals, and then we'd solve for the unknown, which would be 10 marbles.
10 marbles, that's right.
Okay.
Next question, solve 12 divided by 4.
That's 3.
3, that's right.
Okay.
Last question, if x times 5 equals 20, what is the value of x?
Okay, so we need to isolate x. So we divide both sides of the equation by 5.
Right?
And that gives us x equals 4.
X equals 4, that's right.
Okay.
All right, so we've covered number sentences.
That was fun.
Now let's move on to multiplication.
Multiplication.
So remember, multiplication is all about efficiency and repeated addition.
Right, so instead of adding the same number over and over again, we can just multiply.
Exactly. Like 5 times 6 is the same as adding 5 to itself 6 times.
Which is 30.
Right. But when we're dealing with larger numbers, we need more efficient methods, like the standard algorithm or partial products.
Yeah, those are lifesavers.
Now think about this. How is multiplication used in everyday life? Maybe you could use it to figure out the total cost of multiple items at the grocery store, or to calculate the area of a rectangular room.
Oh yeah, those are good examples.
And did you know that multiplication is used in a lot of different professions too? Like scientists, engineers, and even musicians use multiplication.
Wow, I didn't know that.
It's a really important operation.
Okay, let's do a multiplication quiz.
Okay, first question. What is 25 times 4?
That's 100.
100, that's right.
Okay.
Next question. If a train travels at 60 miles per hour, how far will it travel in 2 hours?
Okay, so we multiply the speed by the time. So 60 miles per hour times 2 hours, which is 120 miles.
120 miles, that's right.
Oh.
Last question. If a recipe calls for 3 eggs, and you want to make a double batch, how many eggs will you need?
Okay, so we multiply the number of eggs by 2.
Uh-huh.
So 3 eggs times 2, which is 6 eggs.
6 eggs, that's right.
Okay.
All right, so we've covered multiplication.
We're doing great.
Now let's move on to time.
Time.
So remember, time is all about measuring the duration of events.
Right, and we use units like seconds, minutes, hours, days, weeks, months, and years to measure time.
Exactly.
Yeah.
And we can convert between these units using our knowledge of how they relate to each other.
Like how 60 seconds make up a minute and 60 minutes make up an hour.
Right. Now think about this. Why do we have different time zones across the globe? It's because the Earth rotates on its axis and different parts of the Earth experience daylight at different times.
Oh yeah, that makes sense.
So we have to adjust our clocks to make sure that everyone's on the same page.
Right.
Now let's do a time quiz.
Okay.
First question, what is 1412 hour time?
That would be 2:00 p.m.
2:00 p.m. That's right.
Oh.
Next question, how many hours are in a week?
Okay, so there are 24 hours in a day
Uh-huh.
and 7 days in a week.
Right.
So 24 times 7, which is 168 hours.
168 hours, that's right.
All right.
Last question, if a plane departs at 8:30 a.m. and arrives at its destination at 11:15 a.m., how long was the flight?
Okay, so the flight lasted 2 hours and 45 minutes.
2 hours and 45 minutes, that's right.
Okay.
All right, so we've covered
We're
time.
almost done.
I know just a few more topics to go.
Okay.
Now let's move on to capacity and volume.
Capacity and volume.
Okay. So remember, capacity is the amount of liquid a container can hold,
Right.
And volume is the amount of space a three-dimensional object occupies.
Like how much water can fit in a glass or how much air is in a balloon.
Exactly.
Mhm.
And we use units like milliliters and liters to measure capacity, and cubic centimeters and cubic meters to measure volume.
Wait.
Now think about this. Why is it important to use the correct units when measuring capacity and volume? It's because if you use the wrong units, you'll get the wrong answer.
Oh, yeah, that makes sense.
Like, if you try to measure the volume of a swimming pool in milliliters, you'll end up with a really big number.
Yeah, that would be a lot of milliliters.
It's important to use the right units for the job.
I agree.
Okay, let's do a capacity and volume quiz.
Okay.
First question, convert 5 liters to milliliters.
All right, so 1 liter is equal to 1,000 milliliters. So 5 liters would be 5 times 1,000 milliliters, which is 5,000 milliliters.
5,000 milliliters, that's right. Next question. If a bathtub holds 200 liters of water and you fill it up halfway, how many liters of water are in the bathtub?
Okay, so half of 200 liters is 100 liters.
100 liters, that's right.
All right.
Last question. If a sugar cube has a volume of 1 cubic centimeter, how many sugar cubes would it take to fill a box with a volume of 100 cubic centimeters?
Okay, so we just divide the volume of the box by the volume of 1 sugar cube. So 100 cubic centimeters divided by 1 cubic centimeter, which is 100 sugar cubes.
100 sugar cubes, that's right.
Oh,
right,
good.
so that's capacity and volume.
We did it.
We're making great progress.
I know, I'm feeling really confident about 5th grade math now.
Me too. And you know what the best part is?
What?
We're not even done yet.
There's more.
There's more. We're going to continue our deep dive in the next part.
I can't wait. Okay, so last time we were really getting into the groove with capacity and volume.
Yeah, we were measuring everything.
All the things.
It's fun.
It was fun. But you know what else is fun?
What?
Word problems.
Oh yeah, word problems.
I love a good word problem.
Me too. They're like little puzzles.
Yeah, you have to figure out what the problem is asking.
Right, and then you have to use your math skills to solve it.
It's like being a detective.
Exactly.
Yeah.
So what are some tips for solving word problems?
Well, first of all, it's really important to read the problem carefully. Like really carefully. Make sure you understand what's going on.
Right, and sometimes it helps to highlight or underline the key information.
Oh, yeah, that's a good idea.
And then you can try to visualize the problem.
Like draw a picture or a diagram.
Exactly. Anything that helps you see what's happening.
And then you need to figure out what operation to use.
Right, like is
Yeah.
it addition, subtraction, multiplication, or division?
And sometimes there are key words that can help you figure that out.
Oh, yeah, like total, sum, difference, product, quotient.
Those are good ones.
And then once you know what operation to use, you can set up the problem and solve it.
It's like a step-by-step process.
Yeah, exactly. And you know what the best part is?
What?
Once you get good at solving word problems, you can use those skills in real life.
Oh yeah, tell me about that.
Like, imagine you're at the grocery store and you want to figure out which cereal is the best deal.
Oh.
You can use your math skills to compare the prices per ounce or per pound.
That's a good one.
Or maybe you're planning a party and you need to figure out how much food to buy.
Right, you can use your math skills to figure out how many pizzas you need or how many cupcakes to bake.
Exactly. Math is everywhere.
It really is.
So let's wrap up our deep dive on 5th grade math with a few final thoughts.
First of all, I just want to say that math is not scary.
It's not.
It can be challenging sometimes,
Yeah,
but it's also really fun and rewarding.
I agree.
And the more you practice, the better you'll get at it.
Definitely.
And second of all, I want to encourage you to keep exploring math.
Yeah, don't be afraid to try new things.
There's so much to learn and discover.
And math is everywhere, so you can find it all around you.
That's right. So keep your eyes open and your mind curious.
I will.
And most importantly, have fun.
Yes, fun is key.
Thanks for joining us on this mathematical journey.
It's been a blast.
We'll see you next time.